Gayatri. I am Gayatri, working as assistant professor in EC department at SNS College of Technology. Today I am going to discuss about the topic logic gates, which is under the Unit 1 minimization techniques and logic gates, studied in the subject digital electronics for the students for second year, third semester. Today I am going to give the brief flow of presentation in the introduction part of logic gates and what are the classification of logic gates. In logic gates, and or not, NAND, NOR, XOR and XNOR, we are going to describe each logic gates, their operation and their symbols and their truth table. What is logic gates? The logic gates is a physical electronic device which is implemented by using some Boolean functions. Here the logic gates will be having either binary 1 or 0, and the operation will be performed with many or one number of inputs, and there will be a one output which is in the form of binary. And coming to the classification of logic gates, the logic gates which is classified into three, which is basic logic gates, universal logic gates and the other logic gates. The basic logic gates we know and, or and not, where the universal logic gates will be NAND and NOR, and other logic gates will be XOR and XNOR operation. And coming to basic logic gates, AND gate which performs the operation of AND multiplication, the output of the AND will be 1 when the both inputs are true. In the case that is the input A and B is 1, the output will be 1. Else the output will be 0 in all the cases. And coming to the OR gate, which performs OR operation, just simply we know addition operations, and the equation followed by OR gate, which is Q, which is equal to A plus B. When either one input is true, the output will be 1 in the case of OR gate. And NOT gate, we will know, we will be familiar in NOT gate. It is not a decision making logic gates like that of AND or NOT, but in this it is used to invert or complement the input what we have given. When the input is 0, the output will be 1. When the input is 1, the output will be 0 in the case of NOT gate, and it is having one input and one output. Coming to the universal logic gates, and or are the universal logic gates as we have previously discussed. The and NOR gates are used to generate and, or and not, which is the basic logic gates. Any logical function can be implemented by using and NOR operation. So it is called as universal logic gates. Next we can discuss about the AND gate. AND gate, which is the combination of NOT and AND gate, and which has the output which is a complement of AND operation. When both input is same, which is when the both input is true, the output will be 0. When either or input is true, the output will be 1. When both input is low, the output will be 1 in the case of NAND gate. And coming to NOR gate, which is a combination of NOT and OR gate, and it is also a complement of OR gate operation. When both the input is 1, the output will be 0. When either are the one input is true, the output will be 0. When both the input is 0, the output will be 1. Then coming to the activity based upon the logic gates,
universal gates,
we have
because it will generate
logic gates which is match the following. Then XOR logic gate, which is exclusively OR operation will be performed in logic gate XOR. Input 0 0, the output will be 0. When the input is 1 0, the output will be 1. When the input is 0 1, the output will be 1. When the input is 1 1, the output will be 0. Then coming to XNOR operation, when the input is 0 0, the output will be 1. When the input is 1 0, the output will be 0 0 1 0 1 1, the output will be 1. Assessment question: what are the universal gates? Draw the symbol of truth table of NOT and AND gate. Draw the symbol of XOR gate. Thank you. we have discussed about the logic gates classification, basic logic gates, universal logic gates, and other logic gates. The universal logic gates can be implemented for any Boolean logic function, so it is called universal logic gates. Thank you.